Graphing polar equations by hand is somewhat tricky, and you have to really pay attention to the details. The first thing I want to talk about is the symmetry involved in a polar graph. By looking at the cosine and the sine graphs, notice that the cosine is the same, has reflection over the y-axis. That means that where theta equals 0 is where the reflection is. Now, notice what happens here. This graph is going to have symmetry over this axis, which is where theta equals 0. So notice that these axes are different than these, but this is where theta equals 0, and the top is the same as the bottom. Now, if you look at the sine graph, that has symmetry about the line theta equals pi over 2, whereas that's what this line is in the polar graph, and therefore the left side and the right side are the same. So it's really important to understand symmetries because it can save you a lot of time when you go ahead and try to make a table and plot points. Now, if you're looking at graphing this particular shape, you're going to put theta, and the idea is to put in the fewest points possible to make a table. So when you look at this, I'm going to make sure I choose good thetas to give me easy numbers to work with. I don't want any radicals. So naturally starting with 0, 2 times 0 is 0. And then pi over 6 is because sine of pi over 6 is 1/2, so that's equal to 1. And the next point would be pi over 2. Sine pi over 2 is 1, so that's 2. And then the next point, 5 pi over 6, it's using the reference angle of pi over 6. And you have to remember SATC here when you're figuring out the sine pi over 5 pi over 6. That is equal to a positive 1/2, which means 1/2 times 2 is 1. And furthermore, if you did pi, you would get 0. So let's go ahead and see what that looks like. You're starting here, and then pi over 6 goes to 1. Pi over 2 is 2. And 5 pi over 6 goes back to 1. And then it comes back down to 0. So the shape that you're looking at is this one right here. And the question is, well, what happens if you put in some more points? Well, if I did 7 pi over 6, that's negative. So 7 pi over 6 is a negative 1/2, which means negative 1. 7 pi over 6, negative 1. It comes right back to this point. Notice how it's symmetric about the pi over 2 line, and that makes sense because the sine theta is symmetric over pi over 2. So what's happening is you're going in this direction, and it's going to repeat the same thing. Now, in the next graph, it's 2 sine theta plus 2. So I'm going to add 2 to all of the values in this column and see what happens. Will this shift up 2 units like we've seen before in the XY plane? So I'm just going to put 2, 3, 4, 3, 2, and 1 and see what happens. Do this in a different color. Okay, 0, 2. Again, that's a polar graph, so that's going to be here. Pi over 6, 3. Pi over 2, 4. And I just noticed a mistake that I did. In the previous graph, it should look like this, not that other part. So getting back, I miscounted, that's 2 to this point, which I'm looking at this point right here. Getting back, 5 pi over 6 and 3. And you can see that this is actually going to be symmetric as well. So you know that that is going to look like this and come back down to here, but we don't know what's happening in this particular part. So 7 pi over 6 is 1, which means that you actually have a point right here. And And so the next point would be 3 pi over 2. 3 pi over 2, let's see, I like to draw it, so I know 3 pi over 2 is going to be -1. So let's see, -1 times 2 is -2, so that's going to be 0. That's going to bring me right back to here. And I know that this right side has to be the same as the left side, so that means that this is going to be a point here, and it's going to look like this, which is like a heart. So you can see that this is not shifted up 2 units. It has a different shape altogether when you add 2 to the graph. Let's go on and do one more graph with the cosine, and I'm going to remember that the cosine is actually symmetric about the theta equals 0 line, and I can do this, just do an asymptote there to remind me that the top has got to be the same as the bottom because of this right here. All right, I want to go ahead and get some points. So I have my theta, 1 minus 3 cosine theta, and again, convenient thetas. So 0 gives me 1, 1 minus 3 is -2. Pi over 3 gives me 1/2. 1 minus 3/2 is equal to a -1/2. Pi over 2 is equal to 0. So that means that this is going to be equal to 0. And 2 pi over 3, let's see. Santa Claus says that S is positive, cosine's negative. So that means it's going to be a -1/2. So it's 1 plus 3/2, which equals 2.5. And pi, which is -1, that's going to give me 4. Now let's see what I have. I went from 0 to here. Now all I've got to do is reflect it down, and that should give me an idea of what that graph looks like. 0, -2 is the starting point. Pi over 3, -1/2. So that's going to be a point that looks like it's right here. And pi over 2 is this. So that's going to actually go like that for the first 3 points. Then we have 2 pi over 3, which is 2.5. 2 pi over 3, 1, 2.5. So then it's going to go up like this. And then at pi, it's going to be 4. And I can see that that first point that I did, that should actually be starting here, not here. So again, I made a little mistake there. Sorry about that. So I'm now going to go back and do the 4 pi 4, which looks like this. So the main shape of this, to make it a little bit clearer, is going to look like that. Now the symmetry is up and down, so that means that really there's going to be another part that goes up like this and comes down, which is going to reflect down like this. So let's see, my main points are going to be this, which is 1, 2.5, 1, 2.5, so I know it's going to come down like this. And then it's going to come to the origin like that. And then I know it's going to go back up and come back down like that, more or less. So interesting graph. You could try a different point here just to make sure. Let's go ahead and do that. So let's see, what's another point? I guess 5 pi over 3. If I go to there, it's positive. 1/2, so it's 1 minus 3/2. 1 minus 3/2 is a negative 1/2. 5 pi over 3 away from that is going to be 1.5, so that means it's going to be right here, which is the idea of being symmetric over that axis. So a little bit harder problem there. Real important to be careful with your points. As you can see, I made a mistake there, but caught it when I was going around. And remember your symmetries. Cosine is symmetric about the theta equals 0 line on the polar graph, and sine is symmetric at the theta equals pi over 2 line. We got those from the basic sine and cosine graphs.